Alright, so we should be live now. What's up, stream? Hello, hello. Welcome, welcome. Start the clock. Actually, no, not yet. Okay, so, right, I, got a little distracted. Started watching some things on the internet. I was going to come back, what is it, 2 o'clock we ended? That was 4 hours ago. I was going to spend an hour and a half. Around 4:30, yeah, no, 3:30. I wanted to start again. The next thing. Is that 2.5 hours ago? Yeah, so a little late. Sorry about that. I started watching some stuff on YouTube, and let's just say I got distracted. Got a little distracted. There's a lot of stuff out there that I appreciate. Funny things and interesting things, or just stuff. I don't know. I don't know, man. I get distracted sometimes, you know. But oh man, how the time flies. It's just, oh, not to be ashamed of all that, but just, holy smokes. Yeah, it's procrastination is what it is. I have to admit it. It's just procrastinating. Yeah, just like, don't want to do what I'm supposed to do. Something like that. Alright, let's get to it then. Thinking if there's anything I need for tomorrow. No, I should be good to go tomorrow. We'll just start the clock here and yeah, spend 3 hours here programming. Could have got an extra 2.5 in, I guess, if I focused a little more, but I wanted to know, man. I wanted to see what other people were talking about. There was some, I watched like some comedy for an hour. I mean, I watched a bunch of stuff. That's alright. It's okay, I think. It's okay, I think. So anyway, Levenstein distance. So they give an algorithm here. We're probably just going to implement the same algorithm. Let me see if I could think of how I might implement the algorithm without copying the one from the internet. I think the way to do this, so we'll read the problem first. It says Levenstein distance, hard sequences. Given two sequences x and y, calculate the Levenstein distance of x and y, i.e. the minimum number of edits needed to transform x into y. The allowed edits are. Oh yeah, tomorrow there's a. Oh, I'm going to a funeral tomorrow. Oh, I forgot about that. Yeah, that's what I need to remember before I go to bed. Remind myself. One of my close friends, his dad passed away, and I want to go pay my respects. Yeah, he was a nice fellow. Just remembered what it was. Yeah, tomorrow. Yeah, I'll remember that before I go to bed. I have to remember. So, minimum number of edits needed to transform x into y. The allowed edits are: insert a single item, delete a single item, replace a single item with another item. Warning, some of the test cases may time out if you write an inefficient solution. Okay, so there is it's a dynamic programming solution. The deal is, if the two characters match, right, you can go left to right on both of the, you iterate left to right on both of these strings. And you can say, you can iterate left to right on both of the strings, and you can say, if excuse me. you can consider the first two characters. And you can say, okay, so I guess the recursion would be, suppose that you consider these two characters, remove these two characters, and think about them in isolation for a moment, and then suppose everything that followed those two characters, you counted and made the number of edits required to make the rest of the strings equal. So the rest of the strings are equal, and you've counted the number of edits required to make them equal. The minimum number, it should be. And now consider these two characters. Excuse me. If the two characters are not equal, then you've got to make one substitution. If I think that's it, actually. If they are equal, then it's just 0 edits. So it really only hinges on whether or not that first character is equal. In the recursive case. In the base case, on the other hand, you have only a few possibilities. One, you've reached the end of, basically you're dealing with the two empty strings, right? You've iterated left to right on both strings until you're at empty strings. That's the first base case. The second base case is one of the strings is non-empty while the other is empty. Excuse me, in which case the number of edits is exactly inserting all of the characters that are missing. We know already that an insertion and deletion, they're effectively the same thing. So it's really just either a substitution or an insertion, which then comes down to substituting all the characters that don't match left to right, and then inserting all of the characters that are left over. So this is actually really simple, this algorithm. This is actually extremely simple. And we can even do it iteratively. This is a lot easier than I realized. Why when I first read this, was this so hard for me? I don't know, when I first thought of this, I really struggled. But yeah, this basically comes down to, oh, wait a minute. No, that might not be correct. Because we're looking for the minimum, right? So it could be the case that the characters, no, I take that back. Like watch, wait a minute. Something like this. I don't know, I did that wrong. I'm incorrect, that idea. Levenstein EI. Because you got something like this. Aha. And the problem here is that this, if you say you're going to do 3 substitutions to make this XXX, recurse and say add 6 values, you end up with 9 edits, which is not the minimum because you can do 6 edits, which is insert XXX to the left and insert YYY to the right of this. So actually what you need is a frequency map of the smaller string. Yeah, that's actually the right way to do it, is compare this frequency. I think we could think about it a little bit more, why it might be or might not be correct. If you take a frequency map of the 2 strings and you say, find me all of the characters of the smaller string that are in the larger string, right? The difference of the frequency maps. And you would say all the characters that match, you want to remove, you want to basically don't consider them. And then the characters that don't match, in other words, if there's characters here that aren't here, what you're going to need to do is you can insert and delete. Probably the easiest thing to do would be to make this match the other. And the characters that are not shared, you need to delete them, right, to make this match the other, right? Although in the other direction, you would need to add them to the other thing. So let's focus on going from one string to the other. So all the characters that you in this frequency map that you have. Now there's another problem though, right? That doesn't actually solve the problem correctly either, because then you could say ZBC, ZBA, CBA, right? CAB, let's even do it that way. You could delete the character, yeah, you could just delete and insert for the characters that are missing. But even the order of the characters matters as well. So you can't just use the frequency map, right? Because if you try to use a frequency map, what you notice is actually this CAB and this ABC, you can get the AB fine, inserting and deleting things, but the C will never be to the other side. Actually, the edit distance for these two, I think, would be certainly you have to insert XXX and YYY, so you have to add 6 values, and then you have to delete the CZD, so that's 8. But how do you get from CAB to ABC? How does that work? I think you need to make three things need to change. You need to change. Do you need to change A to C? Or I'm thinking you can do AB and delete and insert C. So you could do 10. I think that's the best if you do it by hand. I think it's the best you can do in this instance. Obviously that's a little more involved though, right? That's a little more involved. Let's check that you guys can see me. Yeah, that's definitely more involved. Very interesting. So the dynamic programming solution. So what we can try to do is a so maybe dynamic programming is what we want to try. The idea would be it's a brute force solution, right? And what you do is you say you memoize each sort of interim solution. And how this works is how do we achieve it? So the brute force solution is effectively try all the possibilities, right? So what you would do is say, okay, let's start these indices at C and X right in the beginning. And we'll say, okay, we have 4 options. We can delete C or delete X. Actually, a few different possibilities, I guess. Delete C or delete X or insert C into where X is, or substitute these values. Substitute X for C, or let's try to go from this string to the other, right? So what does that mean? Well, since C doesn't match X, there's another thing too, is that there's an insertion and deletion, but there's also a substitute. Like you could swap a value for another. Excuse me. You could do a few different options here. We could also assume the insertion doesn't have to happen to the left or to the right, right? So we could say, okay, let's say the C, so C doesn't match X, right? We could insert X, or we could delete C. Insert X, delete C, or substitute C with X, right? Got three options. Deleting C basically means that we shift this forward to the right, or shift it shift to the right one position, the index, and then consider A instead of C. Deleting X, inserting X means that we stay on C, but we shift this index to the right, and now we consider C again and X again, right? So we could delete C, we can insert X, which is effectively deleting X, right? Or we could substitute, which means we shift both of them to the right one value. Those are the three options, right? That gives us, and then we can say is, given those three options, recurse on the subcase, and get the minimum edits of all of those. And we're going to add one, right? We performed an edit, so we add one to the minimum of those three. And we're going to say, calculate each of those three and then take the minimum, edit, and then add one to that. That would give us a recursive solution that's exponential. There's going to be three calls per recursive call. So it'll be, it'll grow quite a bit. What we can do is then memoize that function, and what will happen, we expect to happen, because we're dealing with more or less a relatively small number of possible, what do they call that? Possible, like states, we'll call them. I believe this becomes linear, right? Because we're dealing with I and j ranging over the size of these two strings, and I think when you take the minimum, that will cause it to be, linear. I'm not sure. This could be I times j, big O of I times j, or big O of sort of string 1, string 2. I don't know. That I'm not certain. But we can do it this way. I mean, this is totally plausible, doable. Does it give you linear time complexity? Yes, I take that back. This does give you linear time complexity. I'm sorry, I made a mistake. Because at every iteration, you're moving I one step forward or j one step forward. In some cases, you're moving both, but in either case, you're moving at least one of these things forward. So in the worst case, you're going to do exactly the size of both strings, time complexity. Yes, this is pretty easy memoization, pretty easy recursion. Not bad at all. Not bad at all. Let's code it up. Don't need to change it. It's kind of intermittent. Okay, so I think we're back. Sorry about that. Man, that's really annoying. I don't know why that keeps happening. But yeah, I switched to another network. I think if I switch back, I should be okay. Should be able to switch back soon. We'll give it like, I don't know, an hour or so. Hopefully my phone doesn't die on me again. Yeah, the really miserable thing is that it kills my phone battery when I do this. So it's not great. Also, keep like doxing myself, my network, what the name of it, because I just click it instinctively, like, well, hey, what's going on? But I really should just not close, but go full screen first before I do that. Anyway, so I don't know why that keeps happening, but we'll switch back onto the network shortly. All right, let's code this up. So this is going to be Levenstein. And we can say let. So yeah, start with a let. And we'll do LV. We're going to use recursive memoization here, so this is going to be interesting. Call it LV, and we're going to have two strings, S1, S2, or yeah, S1, S2. We could do just AB. That's fine as well. This is kind of cool, man. This works out really nicely. So just LV of AB, and we say we have three values, index 1, index 2, right, A and B, and we'll call this F, right, and what we're going to do is also give this F, which may confuse you a bit. It actually doesn't need a name, you could just say F as a function. And give F A, I1, I2, AB. Yeah, we could just say S1, S2. I kind of prefer, I know I used AB, but S1, I1, S2, I2, it's fine. So we have three different cases. We say, we take the minimum of these things. So we're going to call F with F, S1, I1, S2, I2. And we're going to say, oh, you know what? The algorithm that I was putting together here, I'm not even sure. I'm missing something here. It's not that simple. I am missing something. They've actually got to match each other, these things. Yes, so you could, yeah, so there is the base case. You do end up with a base case eventually, which is to say, well, I mean, effectively, if you have, you kind of, all right. How does this work, the base case? Well, what it comes down to is if you've made it all the way through one of these strings somehow, and the other string, yeah, I guess that's the way to do it. You just check if you made it all the way through one string, then you've got to take the difference. What's left over of the other string is the number of edits you're going to use. You just add that value, or you just return that value. I think that's it. That's the base case. So there is a base case. Yeah. Once you've reached the end of the string. Yeah, okay, that's fine. I think it is still relatively simple, but it's going to be something like this. So condition, and we're going to say, let's say, so I1 is greater than or equal to the count of S1, right? We're in this case, then we're going to return what's left of S2, which is the count of S2 minus the index. So if we have some picture like this, oops, no. Picture like this, right? So let's say we're at the end here, and maybe our index is here. So 0, 0, 1, 2, 3, 4. There's 5, 6, 7, 8. The count is 9. There's 9 characters. We are, let's say, I plus 1 characters in. We want to take the difference of the count 9 minus I plus 1. Right? I plus 1 just tells us how many characters we're looking at so far. So 9 minus 5 gives you 4 characters left over. That's how many edits you have left to do. Yeah. So it's 9 minus I minus 1. Right? So because it would be 9 minus 4 minus another 1, which is equivalent to 9 minus quantity 4 plus 1. Right? So right, if you hit that case, or you might hit the other side. Both, it doesn't matter which side you hit, you're gonna return one or the other as the value. That's how many edits are left. Otherwise, and this is the recursive part, you're gonna say 1 plus the minimum of calling 3 different functions. And the minimum, we just need to double check if the minimum requires just need to double check if the minimum requires, yeah, those take parameters, right? So it's kind of explicit. 1, 2, 3 functions we can use. Now, what we're going to do is say there's 3 different cases, right? So this is kind of funky notation with this FF. I'll show you what that means. I'll explain what that means later. But you're going to have S1 and S2 don't change, but you're going to have either increment I1, or, and let's do this. Let's do it this way. You have one of these. You have, could even, kind of like this format. You could even, oh, I did that wrong. Let's do I2, okay. And finally, there we go. Okay. And what we're going to do is memoize this function. And this is going to look kind of interesting. Oh, okay. And then we're going to say, we're going to rename LV to partial LV of LV. This is, yeah, it's a really unusual kind of way, not unusual, but it's a pretty interesting way of doing this. And this gives you dynamic programming solutions in linear time. And this should do what we want. Let's just do this. To heck with it. To heck with it. Let's go ahead and do this quickly. Print line of Levenstein equals. Print line equals Levenstein. Let's do that. There we go. Okay, that's what we want. So let's just run it. I'll explain after. See if it works. No. Wait, what? Ah. Oh. Wait, what? Okay. I mean, alright. It's kind of unusual, but it's fine. They're doing multiple spots here. Multiple calls. Wrong number of args, 3. So there should be 6 in each of these lines. Oh. Should be 0, 0 here. Oh, I know what happened. Okay, that's my mistake. False, 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 false. Nice. Perfect. You're kidding me, right? Is this some kind of a joke? Let's reconnect the chat also. That looks like we're there. So, really? You're kidding me. What went wrong? I thought this was correct. I thought this was correct. Let's do something here. Can I run this on a few things? Six. Oh. I see. Oh, that's my mistake. I did make a mistake, huh? There's actually 4 options here, not 3. And that is, if the characters are equal, you can say, that's my mistake. If the characters are equal, you just recurse. You don't increment. Oh, I made a mistake. I made a mistake. Well, you can leave this. It's not too hard to fix this. So you say, I guess we'll say nth. Yeah. Nth of S1 I1 is equal to S2 I2. Then we want to recurse in this way. Yeah, there we go. Let's see how that goes. You don't increment by 1. This only happens if they don't match these 2 characters. I didn't think of that. Oh, come on. Oh, no. I need to. Okay, see the problem here. See the problem. Understand the issue. 0, it says. Oh no, that's not correct. What? Come on, man. Excuse me. That is most definitely not correct. How did that happen? Oh, maybe. Right. So. Okay. Interesting. Maybe this is just not right. What's I2 in each case? Say do. So pretty much this this just kind of went repeatedly. What is even going on, man? Oh no, I gotta leave this charge. Yeah, I shouldn't touch that. Come back and read whatever that is later. 001122665544. How the heck did that happen? What? 001122. Okay. I guess this is a negative number we end up with here. Maybe that's why. Maybe that's the issue. Oh god. Shouldn't. I gotta be careful. What can I say here? Something's not right. Wondering if I'm just kind of off by 1 though. That's possible. That happens often enough. All right, I'm extremely confused because there's got to be a return somewhere here. Like there's some point this returns something. Maybe when what this always this always returns something. And what is going on here? Oh, I know why. I think I should just line run, but oh, it's so confusing. Switching between these two things. make a change, you don't see the, oh wow, okay. So 3 things happen. Here we go, 1, 2, 3, and now we're in this 4th position, right? So we hit this spot 3 times. Then this 4th position, we go end up here, we increment the minimum of these 3, which seems like we end up at 3, 2, 1. So okay, I guess that makes sense. So if we, this, I guess this corresponds to the different wow, you're no kidding, there's a -1 in there. I think that's the problem. I think I had the wrong idea with this count -1. It just might be the problem. But maybe it's not supposed to be count -1. Somehow I did the math wrong on that, I guess. Don't actually know. Oh, that was wrong. Hallelujah. Hallelujah. I don't know, how's it go? It goes. Hallelujah. Hallelujah. No, I'm getting the songs mixed up now, the tunes. How was I doing it before? I said, hallelujah. 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 No, how did it go? There's some emphasis. There's emphasis in the right spot. Hallelujah. 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 No, so there's different tones, right? Like the one that's all right, so I was missing some stuff with this with this approach. Missing 1 or 2 things. Kind of slipped my mind. I think we got it though. But I done goofed. Yeah, it's kind of funny. Alright, I made a mistake. Alright. I made a mistake. I made a number of mistakes. Had to be corrected as we went. But the logic is simple. The idea is straightforward. It's pretty neat. Pretty relatively concise solution. I'll explain what this means, this partial LV thing, what's going on there. Yeah, as described, it's basically, you have the 2 base cases. If one string is exhausted, then return the difference of the other, the number of characters left over in the iteration of the other. And then you've also got, if the characters match, you can just scrub forward. There's not really much. You just iterate on the next with both indices scrubbed forward. And then otherwise, you have 3 possibilities. You're going to do an edit, but you've got to take the minimum of the 3 possible edits. And you memorize each of these to ensure that you get optimal runtime and optimal space usage. And that's it. And what this LV thing going on here is, because Clojure has kind of some trouble, we'll just say, with memoizing recursive functions, especially in scope, right? Not outside of a let. The difficulty becomes, what you end up doing is you pass a function as a parameter, and then you call whatever the passed function is, and then pass it again. So your recursion always has access to whatever function you give it. And then you say, okay, I'm going to give itself, I'm going to give the function I'm calling to LV, right? So then it always has access to itself, so it can call itself. And what we're going to do, though, is we're not just going to give this anonymous function to itself. We're going to give the memoized version of LV to LV. So now you've got you have access to the memoized version in that way. And LV is memoized also. So you've got the memoized function now has access to itself and can call itself. And now you can call partial to bind it to this function, create a function here that has this thing bound. So whenever you call LV, you'll always have this LV function, memoized function, as part of it, and then rename that LV. And that's as if you had a memoized recursive function without really a lot of extra work. It's not really any extra work almost. It's just a memoize and use double function here instead of just one. Pretty neat. And then there you go. And then you eventually just call this memoized function with the beginning parameters. This sort of like a helper function, I guess. Yeah, pretty cool. So let's so that's Levenstein distance. That should be sufficient. Let's go ahead and enter that solution. So I've coded this numerous times now in my life. It's a pretty interesting problem. And looks correct so far. And yeah, I like recursive memoization. It definitely makes dynamic programming a lot easier to think about, a lot easier to do. So very useful for coding interviews. Let's look at the next thing. So what we want to do is ponder for a moment before we move on to the next question. I'm not even gonna look at the solutions to this because this is about as good as it gets. This is like pretty good solution. What I want to ponder is, oh yeah, how do I, what was that song I was singing? The Hallelujah, I was saying Hallelujah a few times. Hallelujah, 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 Hallelujah. Something like that. I like that. I think it's good. I think it's good. Hallelujah, Hallelujah, Hallelujah. Mm-hmm. 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 Not really that original because it's basically but kind of just distorted a little bit. Hallelujah, Hallelujah, Hallelujah. Alright, we'll look at the solutions. We'll do it. Let's see if anyone's got a more concise way of doing this. I like the approach I have here. Hallelujah. Well, basically, these people did the same solution, except they didn't memoize it. I mean, I could have just removed the white space and made this. It's almost the same thing. Yeah, 4 different options. Yeah, it's effectively the same. It's the same. Empty. I could have used that. No. Oh, because they used. Oh, that's interesting. They used. They did something else that memoizing wouldn't work on. They used. What's that called? Well, I'm not sure if it matters. No, it does matter. Yeah, it does matter if they do it this way or not. Yeah, it's not memoized. So they actually end up with. Maybe you don't need to memoize it though. Maybe you don't. I think you do though. I think you do not need to memoize, otherwise you do a lot of extra work. But they actually used the. What's that called? The. What's the name for that? What they did? They used destructuring to sort of get the first and rest values. This is like the head. They call this the tail. And then they said this is everything. It's kind of a neat use of the destructuring, but again, I think the benefits you lose from not memoizing are not worth this. And yeah, I could just like remove white space and make this like one line here. I could also remove white space and make this like, a little more compact. Same thing. I prefer this. I think it's fine. Yeah, I think all of the solutions will give you more or less the same thing here. Okay, let's move on. So into camel case. Let's take a look. Hallelujah. 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 We'll spend another 10 minutes before we'll switch back my internet connection from one to the other, and periodically check my connection here because what do they call that? Periodically check my connection here because it drops on me every now and then. Into camel case. Medium strings. When working with Java, you often need to create an object with fields like this, but you'd rather work with a hash map that has keys like this until it's time to convert. Write a function which takes lowercase hyphen-separated strings and converts them to camel case strings. Excuse me. Excuse me. What? 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 Leave me alone, leave me alone. Leave me alone. Leave me alone. Often need to create an object with fields like this, but you'd rather work with a hash map that has keys like this until it's time to convert. Write a function which takes lowercase hyphen-separated strings and converts them to camel case strings. Alright, well, okay. Fine. 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 No problem. We're just going to do a bunch of replacements, a bunch of regex manipulations here. Or just a bunch of replacements. So first thing we can do is split. You can resequence. Oh. No, that's not what we want. We want to actually do a split. Clojure string split. Let's do this locally first as well. I prefer that. I prefer that. Hallelujah. 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 I don't know, man. I just enjoy that. The hallelujahs. All them hallelujahs, man. I don't know. I just end up breaking into Amazing Grace. I can't. About that. So let's say Clojure.string split on this guy on S. Now what we want to do is map. We want to get a couple things here. Probably use a let x's be this guy, and then we're going to go ahead and say okay. Take the concatenate, or even just Clojure.string join of the first of these x's with the rest of these x's, but the rest of these x's are going to have a map applied, which will be capitalize the first letter. Okay. Maybe we need to write a capitalized routine. Hopefully not. Hallelujah. 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 Oh, nice, we got one. Sweet. Could write a routine, but I'd much rather just use a routine. Capitalize. Alright, let's see how we do. Let's do this. Unable to resolve symbol. Oh, you're kidding me. Clojure string. Nice. Oh. Oh. Oh, 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 oh. Now, can I do this? I don't know if I can. I could try it. Hallelujah. 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 No, I didn't think I could. It's a funky thing that happens with calling functions. Oh, no kidding. Syntax error. Hallelujah. Hallelujah. Oh, that's what's wrong. No, never mind. That had nothing to do with. I think I may have been right the first time. You need cons, or yeah, that should be fine. Let's try that now. Hallelujah, hallelujah. Come on, man. Does this need to be a regex, really? Alright, so I was a little unfamiliar with the split syntax. It's a bit different from the join syntax. The split syntax starts with a string and consumes a pattern, a regex pattern, whereas join can use a string and, or it seems, actually we'll find out now. Seems to take a sequence of strings. Yeah, okay, done. Done. I done it. Done. Alright, done. Can just put this all on one line. One big old beautiful line. Completely unreadable and illegible. Completely and make it completely anonymous too. Just doesn't even matter. Don't mean a thing. Don't mean a thing. Nice. See the solutions of others. What everyone else got going on. Oh, this is pretty good. This is a little more explicit. So what he did is he said, okay, find each of these hyphens. And you're going to match on the hyphen and the value, right? The thing that comes after it. And you're going to return, you're going to use this function on this replace to process what you've got. You get the last, right, of the input parameter, and then you're going to uppercase that, and that's what you're going to return. You're going to use a composition of these things. That's pretty clever. I like that. It's a better approach. What I did, certainly better. Certainly better. I agree. I agree. Someone else did this too. It's interesting. You did a similar solution, capitalizing, but used a group and got the second to get that group capitalized, that string. Interesting. Very interesting. Yeah, I like that solution better. The other solutions are like, yeah, I'll just take the one I wrote. If not this one, then I'll just do this one. Although, well, if not the better, if not the one that I prefer that I've seen from others, then I'll take my own right, or variants of the preferred. And this is kind of interesting. I kind of like this. You know, he uses destructuring to remove the head to get the tail, the rest, and then splits, capitalizes on the tail, or actually I use destructuring rather than just get the X's as I did, and then maps capitalizing to the tail, and then concatenates that with take of the first portion of the whole thing. Take one of the whole thing. And the thing that's kind of interesting here is he could have used cons with this. I would have done it, you know, that's how what I did. Right, could have used cons with this under, you know, the head. You could have done could have used head tail, and then joined at the end. I guess the join doesn't require a string, so let's write ours that way. See what that looks like. I think it failed. I think I did something wrong. You're kidding, right? Oh, that's why. It's destructuring, it's called. Duh. That's my mistake. Oh. Doesn't have a symbol name. It's anonymous. That's my mistake again. There we go. Okay. Anyway, moving on. Pretty neat. Could do it this way too. Just split into tail and head, push tail into map capitalize on the tail, and whatever this is called when you cons. I forget the name of what cons stands for. It's I don't remember. And push the head on the front, and then join everything. You should be done. Cons Clojure. What does it stand for exactly? Construct? Where does cons come from? It doesn't explain. Conjoint, no. I think it's construct, as in construct a list, a Lisp list. Anyway, so that's kind of neat. Done with that. Neato. Next, generating K combinations. Okay. Difficulty medium, sequences, combinatorics. So, given a sequence S consisting of n elements, generate all K combinations of S, i.e. generate all possible sets consisting of K distinct elements taken from S. The number of K combinations for a sequence is equal to the binomial coefficient. What? Given a sequence S consisting of n elements, generate all K combinations of S, i.e. generate all possible sets consisting of K distinct elements taken from S. That's n choose K. The number of K combinations for a sequence is equal to the binomial coefficient. Generate all the sets. Oh, well, that's interesting. Yeah, it's n choose K. Sets. The number of them is n choose K. Yeah, you know, no problem. But you can do, there's a few ways to do this, but one possible approach is to generate the power set and stop at, generate the power set and stop at the last iteration, and then filter on the sets that have K elements in them. That's one approach. Maybe not the best approach because it generates the whole power set, which is kind of a lot. Although binomial coefficients are tend to be rather large anyway. I'm not sure if it matters that it's exponential or not. It's like the dumbest way to do it is to just create the power set and filter on. I mean, you can create the whole power set even. You don't even need to. I was thinking of generating just part of the power set, but actually you could generate the whole power set and just filter on what you need. That might be like the easiest way to do this. Right, you just filter on the size of the sets. I'm tempted to just do that and move on. Kind of don't care that much. Now the other deal is maybe there's a way that doesn't include generating power sets. I'm curious, I'm wondering. There's a way to do that. I don't know. I don't know, man. I do not know. I do not know. I'm thinking, Now, what I've been thinking about, earlier I wrote a recursive backtracking algorithm to do a depth first search over a graph. It doesn't revisit the nodes that it already visited. I thought that routine was rather clever and also well, I guess it worked, and it was kind of quick to write, sort of efficient. It was sort of pretty, I don't know, qualities about it were kind of nice, things that I liked about it, the routine. And I'm thinking about writing a similar routine to do recursive backtracking here, such that we can generate each of these sets. And I think I can do it. I think it can be done. I'm pondering it now. And that would be preferable to the power set approach. Also, the thing is, interview questions are often ask for something that requires recursive backtracking, and to iterate over sort of a whole bunch of sets of things to sort of do an exhaustive search. And it's it's used often enough where it's important to know. It's good to know it. So maybe a little bit of practice with that, like, because I might be asked, like, just whip one of those out, just off the cuffs, which yeah, that would be difficult, interesting. What am I getting at here? Difficult, interesting. Doing it off the cuffs would be kind of challenging if I haven't practiced it. So let me try practicing that. Let's grab each of these test cases first. We got 6 of them. Hallelujah, hallelujah, hallelujah. Hallelujah, hallelujah, hallelujah. Na 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 na. Hallelujah, hallelujah, hallelujah. What do you call this? This would be K combinatorics. K-com, we'll call it. Should be fine. Oh, okay. It goes K in a set. Let's say. So it takes a few things to perform the recursive backtracking. You don't actually need f, we can just call f, but we do a reduce over using itself, which is kind of interesting. So the inputs are important, and we operate over, now we can say, right, so there's sort of the rest of elements, we'll call it our x's. So you call this function, you have this function, and it has, now I think what we want to do is actually, well, okay, fine. This will be kcomb. That is the recursive function itself. There won't be necessarily a let. Now we might want to use a let here. You know, maybe want to use a let. More likely than not, you're going to want to use a let. Hallelujah, hallelujah. Now the thing I'm wondering about is I kind of want to wrap this function. So let's say, yeah, we'll come back to that. Yeah, we'll come back to that. Let's say, let's just go with kcomb for now. Just hold on for a minute. We'll come back to, we'll write a, I guess anonymous wrapper that'll call our recursive function and just change the parameters so it looks, so, you know, sort of, what do they call that? Uses a syntactic sugar. All right, now what we want to do is use this let. This really should just be x's, k, x's. We can give an I, put an I in there for which index we're at. And we're going to say something like, and then there'll be also return value. So what we need is, we're going to be reduced, right? So new value, and the rest of this, yeah, it gets called here. And we have the x's, okay. Have the value itself, we've selected. And we say the k, we just want to keep passing this, I think. Like these are things I guess would go in our wrapper. Maybe we should create a proper wrapper for this, I don't know. Not really sure. I guess one of those reasons why you would want to practice this depth first search. The I is how many elements we have so far, although that's not entirely necessary because we can just count what we've got. But this is the so far part. Let's do ret. Yeah, let's do that. Or do stack. It's better. Yeah, what's on the stack, and k is right. Okay, we can do it this way. So initially the stack can be empty, and then k is an input that doesn't change, and then we're going to take the rest of x's each time. So we'll in our let, we're just going to redefine ret, I think, which is whether or not we add what's in the stack to ret. This is ultimately what we want to return from our reduction over our recursion. And we have the rest of the x's. We just keep track of what values at this particular point in the iteration are left over in the list, and we operate on those values. So we can just say this is sort of like the neighbor set. Neighbor set is going to be rest of x's, and then ret will be, say, if the count of stack is equal to k, then we will conjoin set of stack with ret and return that, or just return ret. And the neighbor set is really what we want here. Well, it's not a particularly difficult recursion here. Okie dokie. And you reduce this function over each of these. And yeah, when the neighbor set's eventually nil, this doesn't do anything. Yeah, I mean, we could do something like this, like another let inside here, and put these things. So this is the definite. Make a wrap, build a wrapper for this. Call this a function. We'll call it just anonymous function. Well, no. K-comb helper, I guess. Or even just F. I mean, it doesn't really matter. Yeah, K-comb helper, I think is a little more descriptive. Let's call this depth first search, or yeah, just a depth first search. And that'd be a function. Takes certain parameters. What am I missing here? So this is a function. This is your let. There's your, yeah, that seems right. And then finally we just return okcom DFS. This can then be not abstracted, but you don't have to consider the details. Just use x's, I guess. And this will be, so the initial stack will have an empty set or empty vector. The k doesn't change at all throughout the whole algorithm. X's are x's initially. That ought to be a set. Ret is going to be a set of sets. And you're going to call this function, you're actually going to call a reduction on this, reduce with okcom DFS with this initial state over the x's. Nice. Nice. Oh, wrong. Did that wrong too. Okay. Whoa. Alright, let's see this now. What happened, man? What happened? Only 4. 465565. Oh, come on, man. Not this again. It keeps... Oh, no. Oh, there goes the internet. Come on, man. Not again. Not again. Alright, we back? Okay. There we go. Holy smokes, man. That is crazy. Oh. I don't know what's happening. I don't know, something up with the network maybe? Who knows? Who knows, man? That's a pain in the neck. What a headache. So let's get back to what we were doing. Normal. Yeah, I don't know what that was, but fortunately it looks like the main line is connected again. So, yikes. I think part of the problem here is there's a few things to think about here. So one thing is, yeah, my phone died again for the 1000th time. Eventually we'll figure this out. But something's up with the network because I pay for internet, but it just doesn't work sometimes. I don't know what's going on. It's very frustrating. Don't know what to do about it. So there is something here in that what is this stack? 465, 565. It's just 4656. So there's some funky things going on here. Number of things, issues, I guess. One issue is 456. So this reduce doesn't quite do what I think it does, I suppose. Oh, that's interesting. So I think part of the problem is that we push onto the stack first before we, yeah, I think, okay, I think I see an issue here. It's actually, oh wow. Um, hmm. No, but that shouldn't matter. Um, hmm. I think I need to do a map here. See, that's the thing. I get a little confused between a reduction and a map. If I should use one or the other when I'm performing these depth first search, exhaustive search things. Because this is more of an exhaustive search, I think. And what I think you're going to want to do is no, I don't know. I don't know. Huh. You got this stack of things. Like what you would normally do is you do like this recursive algorithm where you select an element, push it onto the stack, and recurse on all the other elements that are left over, right? And then somewhere in there in the recursion, I guess the base case would be if your stack size is equal to k, then you push that onto something else that you return. That's sort of a global variable over the iteration. Like that was the easiest way to do it. That's how I would do it normally. I would use Python to do that as well. But you don't want to use mutability at all here. So you want something that quote unquote global variable is going to be this ret variable that we're passing back and forth. And that's fine. But it seems that you would need to want to use a reduce out if you're doing it that way. But you change your neighbor set each time you execute this. And First you operate on 4, and then you say, you know, the stack is 0, so we don't change ret. Push 4 on the stack. And then you've got 5 and 6 to look at. I want to say there's got to be a base case in here somewhere. Maybe that's what I'm missing. But it's not even the base case. It's really the problem, because it seems like we're not iterating over everything, right? Like there should be 4, 5, and there should be more stuff in here. Also, I don't know what happened here. How do we get this? Guess we just conj things like crazy. I don't know. I don't know what's going on. I don't know what's going on. I think maybe it is a map that we want to use. I don't know. It seems like it should be a reduce, actually. Maybe even a map reduce. Maybe just map. That's confusing. Maybe this is a good application for a transducer. As odd as that is. I don't really like using transducers much. Kind of give me a headache to think about. I want to say like you want to iterate over the sequence. But it's more like you want the indices of the sequence. Like you want the drop the first value, drop the next value, drop the next value, operate on each of those. It's kind of what this function should do, right? Should I feel like I'm missing something, you know? Something's not quite right. Something is just not quite right. Well, excuse me, for starters, we can use this if. We say if these are equal, then you want to return this here. No reduction on this either. Everything is the same, but ret has one more set in it. Right? That would be right, and the stack is here, and otherwise we keep going. Now I don't know what this is going to do for us here. Oh, this is also supposed to be pretty simple, like brute force. I don't know why I'm struggling so much with this. I guess I need more practice with these things. I guess I need more practice. Once I see it, I can memorize it, but before then I'm kind of like flailing about here because it doesn't really work right. Four, 6, 5, 5, 6, 5. And we keep just pushing something onto the stack, right? I think it's supposed to use a map for this. I don't think you can get around that. Although it's a tricky thing because it's a tricky thing. I want to say you'd use a reduction in each case. Yeah, you know. Oh, I don't know, man. Shucks. Shucks. I want to say maybe I should use a lazy sequence of sort of removing the first element. Right, lazy sequence of rest. And then iterate over that sequence. Not reduce, but map over that sequence. And oh, I don't know, man. I kind of want to go like lay down and think about this. Sit down and think about this. This is like, holy smokes. Ah, my brain. Thought this was going to be easier. What happened? What happened, man? Oh no, maybe I should just lay down. And my phone is off. Phone is not charging. Ah. Gotta be kidding me, man. It's terrible. See if I can get it to open up on 8% juice. Turn on. Deep breaths. Gotta breathe, man. Just breathe. It's all gonna be okay. It's gonna be okay. Just want to set an alarm so I can go lay down for a few minutes, 5-10 minutes. And then we'll think about this problem. Oh, this is terrible. This thing is just kind of dying. There's no way around it. It's on its way out. It's on its way out. There ain't no way around it. Also, what happened to the clock? Oh, it's gone. Oh no, it's there. We're okay. No, but it reset. Nice. I think I was gonna do this for one more hour anyway. Set an alarm for like 15 minutes. Go lay down for a minute or two. Yeah, we'll do it this way. I'll be back. I'll be back. Let me just think about this. Gotta just ponder it. Got to just ponder it. What are we doing here with this? What are we doing with this? So, oh, okay. What are we pondering here? Kind of just want to sit, lay down, and listen to some music, man. All right. So the normal search or exhaustive search would be you have like a neighbor set. Select an element of this set, and you're going to recurse over each selection of the set and operate on the I guess what's left over after you select that element, and it's select an element. It's select an element, recurse with that element selected, and then after you finish recursing, pop that element, remove it from the set that you're interested in operating on. Maybe that's the problem. Maybe the stack. I need to pop the stack during the recursion. That could maybe be an issue. Think about that though. That might be the only problem. It may just be because we're doing a reduction. Reduce should be fine. You know, that actually shouldn't be an issue. It's just maybe think about that. You know what? I'm wondering if reduce is part of the problem. You're supposed to call this function recursively. The reason why I would think the reduce shouldn't really be an issue is because we've got state you're trying to manage between calls, so you'd want to use reduce, but you also I guess after the call is finished you want to pop something before you, but that should be fine too. You could just put that in the reduce, like in the function before you call the next thing, you pop. How does that work? What do? You push something on the other on the stack, then call this thing recursively. That works. Then after you're done recursing, then you want to select the next element, pop from the stack, select the next element. Actually, I don't know if you could do this with reduce. Yeah, I don't know. This is kind of hard to think about. Difficult to ponder. Do I even need reduce? The reason that I want to use reduce is that there is some state that I want to maintain between all of these calls. Now, why wouldn't we be able to just pop? The problem has something to do with, like, excuse me, like you make this recursive call and you get a whole bunch of values. You get a whole bunch of pieces of the return, what you want to eventually return. And then what you do is you pop the stack, push the next element on the stack, and iterate again, right? Recurse. It's kind of awkward. Also, I think these sets are, what's the word for that? Indexable, I want to say. So you can like get the first element of the set, get the second element, etc., etc. Excuse me. Oh man, this was a lot easier when I was doing it in Python. A lot easier in C++ as well. I think it's more just a matter of practice. Like I'm not super practiced with these things in Clojure, using either reduce or map. I think map could be okay, but there's an issue of like what I end up returning, something like that. I don't know, man. I actually just don't know. My brain. My mind. My mind. You could pass the return value through all of the function calls, and that would work out okay, I believe. I'll just kind of keep building over time. No, you really want the reduce to get what you've operated on, what the results were or are. Oh my goodness. Oh my goodness. Pondering this here. Pondering this. Think about this again. Think about this some more. We want the so reduction is not too bad. Maybe we want to map and reduce. No, or a double reduction. That seems kind of bad too. I don't know. I just don't know. Excuse me. I wonder if what I should. Oh, that's interesting. Okay, maybe what I should be doing is putting a return statement after the reduction call. Ah, that must be it. Actually, that would make a lot of sense. Maybe that's the problem. Okay. I think I know what to do. Thinking I know what to do. Oh man, there's a whole lot of it's just recursion upon recursion, I think. Recursively calling recursion calls. Excuse me. Excuse me. Uh, Now, what makes it particularly challenging, I think, is that when you use a reduce in the way that a recursive reduce, you're not really. It's not the same thing as recursion anymore. It's a little more complicated than that because you're calling a function that's, in theory, it's like iterative. It's somewhat iterative what you're calling at that point, and so it gets kind of difficult to process, to think about, to understand. And I'm actually struggling to understand that now. Like, what would I be doing if I were to use this recursive reduction? I think I can add a call at the end which returns just the stack we started with, right? Instead of popping the stack, just the stack that we started with. We could do that. But the problem with that is, and then I could maybe use a map to. I'm thinking maybe I should use an index into the set that we're operating on rather than trying to pass sort of removing the first element from the set. I think better would be to pass an index and then you operate only on incrementing the indices, something like that. Well, you could use an index and then drop the elements from the index. The problem with that, though, is that you're doing a lot of extra operations, dropping things from the sequences, which I think is really unnecessary. That index effectively defines a starting point within. Hopefully, the set is sort of random access. I think it is. It's just you need kind of like a for loop, though, if you're going to do it that way. Which I didn't really want to use a for loop, right? Because using a reduce doesn't really work anymore. It doesn't quite work. Kind of don't like the idea of using a. Well, you could use a range, maybe. Yeah, I guess that works. Reduce over a range and a numerical range, and then just map those values accordingly. suppose that works as well. Oh man. Oh man. Oh. Oh, you're kidding. Give me more time. No. Okay, another 15 minutes. I was enjoying that laying down. Enjoying that laying down thing. It was nice. Shucks, man. Shucks. Okie dokie. Excuse me. I don't know, man. I have to sit and think about this for a while. No. No. So, okay. I mean, all right. Let's suppose that. How do we even do this? If you map this function to a bunch of different things, like a bunch of it over a range of indices. Yeah, I guess that could work. Perhaps, potentially. And what do you end up with after the mapping here? I guess what do? You recurse maybe? So what it would be like is if you select an element, right, and then push whatever's there that you mapped to, push that onto the stack, and then recurse with that stack and with that also with that value as parameters. So this new updated stack and these parameters. And I guess you would. So you've got this stack, right? Each of these mappings would be a new vector, right? Each of these vectors with this new value. Yeah, okay. I guess map is what you want. And then what's the return type though of this map? Like, what do you get? You get a sequence of, okay, recursive calls with this new stack and this index into, like, you're gonna only use stuff after this set, after this index. And I guess whatever that index is, right, that's what you push into the stack. Okay, fine. But when do you return? I guess you gotta have a base case somewhere where you actually return. I guess you end up returning, given that value in the stack there, right? You return all of the k combinations of that size k that begin with that element in the stack. Yeah, okay, all right. And then, so you get this set of sets, right, at the end of this all. And I guess the sequence of these sets of sets, because of this mapping, right, you're going to end up with a sequence of these sets of sets. And actually, you could just push that all into a set and return it. You don't even need to do any popping or whatever. So you don't really need to reduce anymore either. Yeah, I guess that works too. But this is like not. This is not simple at all. This is like a whole to-do, this thing here, doing it this way. This is a whole to-do. Wow. Yeah. Okay. Wow. 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 Oh boy. Um. Hmm. It's kind of a problem here. Uh-oh. Hmm. Yeah, I guess you get a sequence of sets, right, ultimately. And I guess you just take the union of each of those sets at the end. Yeah. Actually, you could just do a simple reduce over that, or even just push each of those, reduce over that to push those into a return set. It's fine. Okay, excuse me. Okie dokie. Oh. Okay, I guess I have to code it now. Thinking about it. You've got each of these, or you got this index that you give it. You can join onto the stack. You recurse. So no reduce here, just a recursion. And the base case is, right, if size of the stack, and yeah, all right, I guess map is what we need. I don't know why, man, for some reason, strikes me as odd that I cannot use a reduce, simple reduce. I don't know. Not really sure what to make of that, or to think of that exactly. I don't know. I do not know. I guess in a minute or two we'll go code it up. boy. Sorry, my mind is just completely wandering now. All right, what is this going to look like when we code it? I mean, I could go sit down at the computer and take a look at it, but I kind of want to just lay down. I mean, this feels really good. This feels really good. I'm going to bed in a few minutes anyway, and we'll end stream shortly. This will probably be the last problem we attempt. We'll attempt it. If we get through it, then we'll look at the next one. Otherwise, just go to bed. Yeah, all right, we'll use a map, and we'll map over the function, map over the range of indices from a given index that we start with, or as one of the parameters, one of the arguments, and we get the value of our set of elements, which also gets passed around throughout the whole program, through every function will have access to the set. And we push onto a stack each step, whatever values at that index, that gets pushed into the next iteration in the map as an argument. And so we'll use an anonymous function here that sort of sets the parameters correctly, and then we map. Right, obviously we map this anonymous function. The only argument that the anonymous function is going to receive is it's kind of like a binding on all of the other parameters, but obviously it's a little easier with the anonymous function in between. And we're going to say, right, range only over the things that are greater than the input value I. Yep, okay. And there's a base case, right? Before all of this, we say if the size of this stack that we're looking at is equal to k, then we just return, I think it's a set containing one set, which is, yeah, we'll do it that way. A set containing one set, which is that particular, the stack converted to a set, right? And then otherwise we perform this mapping. We do a bunch of, I guess we'll just use a do command, and we perform this mapping. What we really want to do is, I think, use a let command, not even a do, but a let, and perform this mapping to get and name it something. Call it like, I don't know, like recursive sets, or just sets, we'll call it. And then we want to perform a reduction over those sets, which those are all sets of sets, and we'll push all those sets into a single set. So you just do an into and an initial empty set, and push all those sets in there. What's contained in all those sets, and then you get a larger set of sets, and return that. And yeah, that ought to do it. This might end up being significantly less than I thought. Like kind of terse code, after all, actually, because it's not that many steps to do here. Hopefully, we can do that right. All right, let's try it. Also, just make sure my phone's still working here. Yeah, we'll just say at 9 o'clock we'll go to bed. And that's the end of that. Okay. Yeah, I don't know. I wanted to try to use a reduce for this, but it just doesn't seem right. Also, I need to charge my headset now too. My phone needs to be charged, but so does my headset. Yikes. I don't have enough chargers. It's not great. I can always... Well... Okay. So... Yeah, let's do what I was just suggesting. So... Let's get rid of all this. Well... Can leave this as it is. So we're not going to call it a D. I don't know what to call this. It's not really depth first search. It's just a... I don't know, helper. We'll call it helper. And I got this F. So it's going to take a few things here, but we want to use an if statement. And the if statement is going to be if the count of the stack is equal to k. So we'll make sure we have the stack, make sure we have k, gotta have your x's, and we can have an index that we're interested in. And then we'll say, if this is the case, then we want to return a set of one element. Set containing a set. It's like the set that contains the set. Otherwise, we'll use a let here and say let sets be this mapping of f over, in fact it's going to be like this, a function called f, which takes this percentage, which will be a range of increment I to count of x's, that range. Right. This function we map over, and we take conj of, we're going to nth x's of I, and this is going to be the stack, and then we have x's, k stays the same, x's stays the same, but I changes over this range, right? See that? So we map here, and then we have a call here, which is to use into over sets, and we reduce. It's actually a reduction. No, yeah, a reduction. Reduce into this set over sets. And the function we're going to use is an into. Could actually just do into it in and of itself. I think that works fine. Yeah, it seems to be what we want. Something like this. Call it cake home helper. And just plain old cake home helper with stack at k, x's, and I. So stack will be empty, k is the same, x's is the same, and I starts off initially 0. What happens now? Whoa! What happens now? How do we do? How did we do? How did we do? Nth persistent hash set. You're kidding. No. No. Come on, man. Shucks. Alright, we can use a vector then. Make a vector out of this. And say... Could try again, I suppose. Well, I wonder what happens here. Wrong number of arguments passed to persistent hash set. Arity exception. Where is that happening? 107? No. Where? It'd be nice if it said where this is happening, this extra wrong number of arguments. Wrong number of arguments passed to persistent hash set. 0. What? Well, that's extremely confusing. Where is that happening? What's going on? How? How is that? What? It's a syntax error. It's a compilation error. It's not even... Where? Where though? I don't understand. Come on, man. Is this the issue? I mean, it can't be this, right? This is... Where I don't know where this is happening. That's having an issue. Oh, okay, it is this one. Really? No kidding. 1, 2, 3, 4. 1, 2, 3, 4. No kidding. I mean, could do this too. Hopefully that works. I don't know, man. Persistent hash set. Where is this? What is going on? I don't think it's this one. It's the problem. I think it's something else here. Something else is wrong. I don't know what it is though. I gotta like locate it. What is going on here? We'll start with this just to see if this compiles. Okay, it does. So it's something inside here. I don't think it's this one. I mean, it could be. That wouldn't make a lot of sense to me, though. Okay, so that's fine. So there's something with a set that isn't making any sense. Let's see if it's in here. I don't have too many things to look at, but it's a really weird error because it doesn't really give me much to work with. Okay, so it's here. It's literally just reduce into. Oh, okay. I think I know what's happening. Okay, I think it's got something to do with. I think I know what the issue is. I think, yeah, something funky is going on when I use just into. It looks. Oh wait, what is happening? Huh? What is going on? Truly do not understand. What the heck is going on? What? Is this not doing? What the heck is happening? Oh, that doesn't make any sense. That don't make no sense. I think we need. This would have taken me a lot less time if I just went ahead and used wait a second, union. This would have taken me a lot less time if I just went ahead and used the power set, filtered on the power set. Yeah, it's not Clojure.set. How come I have to, do I really need to Clojure.set? I mean, okay. Fine. Fine. You gotta be kidding me. You gotta be kidding me. Ah. Ah. What do you mean wrong number of arguments? Where is that happening? Where is that happening? Maybe it's just, I can't call it sets. Let me just call it, you know. I don't know what to call this. Z's or something? Who knows? Maybe that's the issue, just calling it set S screws up the compiler. What the heck is going on? What in the Sam Hill is going on here? It actually has nothing to do with this, what you end up returning. What do you mean? What? 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 What the heck is going on, man? I don't get it, man. I don't understand. What is happening? What? What? I am utterly confused. Just completely confused. Entirely confused. Confused beyond any redemption here. Why would this matter here? Like, why would this make a difference? Like, this doesn't make sense. It just doesn't make any sense. Arity exception, wrong number of arguments passed to this persistent hash set. Where? When is that happening? When does that occur? Is this thing? Is that it? It just doesn't. I mean, okay. So somehow this map function just causes issues. Not clear at all to me why. Why would this matter at all? What is even the problem? Okay, that's a little bit better. Maybe it's because oh, maybe that's why. Okay. I guess because this decided to interpret this as a hash set with no arguments. I don't know. It's really weird. Didn't really make any sense. Okay, all right. This is a little bit better. Do get something weird going on here now. Also, there's a lot of nils in there. I could use union, I guess. Yeah, I guess that makes sense. Can go back to sets. Holy smokes, man. Sometimes you get these errors and they just blow your mind. False, all the way across the board. Nice. So I like to see. Also, does this work? Can I just do this? Can I be just completely confused for once? Okay, nice. Alright, sweet. So, yeah, I mean, you know, this is not terrible, I think. What happened though? So there's something with nil in here that I was thinking might be an issue, and we'll see shortly what that is. Right. So we just get 4. What? Why, maybe this needs to be a -1 initially. Maybe that's the problem, after all. No. Sweet. How does that even happen? Oh, because this, you call this first. Yeah, I mean, right. Okay. Huh. Maybe, it's supposed to be 0. Which is supposed to be 0. And then, actually, maybe just want, this is kind of funny. This is like calling F with All right. This initial stack. Maybe this is just empty initially. This is Is this what I need to do? Is this what we gotta do? Okay. Yeah, I mean, perfect. You know, everything's fine. There's no way this can pause. Nice. Does this work at all? Probably not. We're gonna try it anyway. Yes. And to not support on this type hash set. Yeah. I mean, of course. Of course. Okay, we got 6 and 4. Why would... What is going on? What is even happening anymore? I don't understand. This is nuts. This is not working the way I thought it would. This is like embarrassingly not what I was expecting here. No, this is perfect. This is great. This is fantastic. What in the Sam Hill is going on here? 4 and where's the 5? What happened to 5? Why would... I guess... Like, what is... I mean, you know... Everything's fine. Everything is fine. Yeah, you know, this is good. This is really good. Don't understand what's going on here. I think I made a mistake. I don't know what I did wrong. New version of WinSCP is out, so that's good. And holy guacamole. Holy smokes. Oh, okay. Yeah, now it works. Of course. Of course. What is even going on anymore? I don't know. I don't know, man. I don't know, man. You know, I don't really understand why these things are happening the way they're happening. This isn't supposed to be a set. It's supposed to be a stack. A vector. It says 0, 1. That's a good question. What's going on there? Oh. Why is Windows CPU open? I guess I clicked that on accident. You're supposed to have 0, 1, 0, 2, and 1, 2. But somehow we just got 0, 1 and that was the end of it. Just said no after that. Okay. What? So we call this a few times, right? So call this for each value over this range, so 0, 1, and 2. And so when you have 0, there's two values to consider, 1 and 2. So this will be false. Then you map again, but this time with I. Oh, that's interesting. So we would call all of these with 0 initially, though. See, that's the thing that kind of trips me up. Like, why? Okay. I don't know. I don't know what the issue is here. I don't know, man. This should be fine, actually. This should work. Why doesn't this work? I think this is exactly what I'm supposed to do, but missing? What am I missing here? Something's not right, but it's really small detail must be. Like if we did just 0, 1, 2, right? First just the zeros, yeah? So range over this count, so we have 0, 0 on this function with, this is the 0th element, 0, k, which is 2, the element 0, 1, 2, and a vector, and then 0. And so we call this and we say push nth of I, which is 0. So maybe this should actually be increment I. May have something to do with it. Could try that. No. So 0. So that this stack has the 0 in it, and we say, okay, this I is now 1. Let's range over, oh no, this should be 0. I'm sorry. Still, range over 1 to 3, or 1 and 2, with this I, which is 0. I mean, these could be empty. That actually doesn't matter. Yeah, that actually just doesn't matter at all. Okay, apparently it matters. Why does that matter? What is going on, man? What happens with this 6 and 4 also? Why is that happening? What's going on with that? What's going on with that? So we push on the stack this element, which is going to be 0 or 4, right? And then we range over 4 to 5 and over 5 and 6, and we map. So it'd be 4. Oh. Oh. Oh my goodness. Duh. That's really okay. I'm just freaking, my brain is turning to mush. That's why, because I'm not even, alright. Don't mind me. My mind is turning to garbage. Yeah, okay. And, right, because you're going to push onto the stack each one of these values and then recurse. Do you need to? What if you just called this once? Empty stack. K, X's. And the last thing is I guess starts off at -1. There we go. Oh my goodness. Wow. Hey, everything's fine. Everything's fine. Everything's peachy keen. Nothing is wrong here. Absolutely nothing is wrong here. Everything's fine. It's fine. It's all fine. Ah. 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 Oh, that's like depressing. That took so much time. That just took forever. pretty easy. I mean, I shouldn't say easy, but I think, yeah, the more I finagle with Clojure, the more I'm going to have to choose between map and reduce when I'm dealing with certain functions. It's kind of tricky, man, doing things strictly functionally. It's definitely a tricky thing. But yeah, it's pretty wild. That was it's good. That's good. That's great. That's just fantastic. Fantastic. Oh no, not what I wanted. Jeez Louise, man. Oh, you gotta be kidding. Gotta be kidding me, man. This is ridiculous. Look at the solutions, and we'll also take a look at right Roman numerals. We'll leave the solutions, we'll leave this for later. Tomorrow we'll take a look. This is the inverse of number 92, but much easier. Give an integer smaller than 4,000, return the corresponding Roman numeral in uppercase, adhering to the subtractive principle. I think this is not easier. I think 92 is pretty easy. This is easier? I don't know, man. Is it? They gotta go from the number to the numerals. Seems kind of questionable. Oh, I guess it's not that bad. Yeah, because you can just go digit by digit. And that maps to different pieces. Yeah, I don't really like that though. Depending on the position in the digit. Only got so many options to work with. If it's a 9 or a 4, you've got something subtractive. Otherwise, you would. Otherwise, you're just throwing a 5, and if it's a 0, there's nothing. If it's a 1, 2, or a 3, or anything above a 5, that's not including 9, you're gonna throw a sort of 5, quote unquote 5 value in there, which is there's like a 5, a 50, and a 500. Anything above a 5, you throw one of those in there. If it's not a 9 or a 4, and not then if it's a 9 or a 4, you've got to kind of use something explicit. Thinking how I can do this in like a way it's not like I don't want to just like directly map. I mean, I could just build a direct map for this, which I don't want to do, but you could do it that way. I would say the other one's pretty easy. Yeah, the other one's pretty easy. And the solutions to these, some of the things are a little more concise. Oh, yeah, some people did just build the power set. It's the heck with it, dude. Just build the power set. Yeah, I think the ones that built the power set were a lot more succinct than the ones that didn't, or would probably look like mine. It's fine. I like this better. I think I like this better. Anyway, yeah, we could look at this later, tomorrow. All right, let's end it there. Oh, and I'm sorry. I completely forgot I had that up for the past few minutes. Sorry about that. Hopefully you could see all of what I was doing. Yikes. Sorry about that. That probably was really obnoxious to look at. So thank you all for watching. Talk to you all soon. Thanks for hanging out, saying hello. I don't think anyone said hi. I don't know if anyone even came by, but thank you for watching and have a good rest of your night. Yeah, I mean, these videos are like super unpolished because it's just me like working. I mean, it's me just not working, but just practicing. and really doing quite a lot of struggling with a new language, and I guess certain programming techniques that I'm not familiar with this language. Yeah, how I would otherwise do it. I'm a little more comfortable, different with Python as an example. All right. Yeah. So thanks again. Talk to you soon. Have a good rest of your night. Take care. Take care. Good rest of your day. Take care.